All right, this is Dr. B, and welcome back, everyone. It's great that each and every one of you is here tonight. I'm excited to do some chemistry. We got a demonstration tonight. We're actually going to try to make this stuff right here in the beaker, this multi-layered precipitate type looking thing. So last Tuesday, we had some technical difficulties there with the sound where I was getting a double voice. So I hope my voice is clear this evening. I'm sure you'll tell me if it isn't. Let's see. All right, Loretta made it here. Excellent. Excellent to have you here. So, Loretta, how's my sound? Can you hear me without any echo? So that's the big question for me tonight. You know, it's kind of interesting because for me, when I started chemistry, it was really kind of challenging. Like there were a lot of things I didn't understand that seemed kind of mysterious. And over time, I really learned how to do them well, become a chemist. And with streaming, I'm kind of in that same place where I'm trying to learn to do all these things really well, but some of it's a little bit confusing still. So we'll learn some streaming and some chemistry together here. All right, I hear that my sound is good. Excellent. So let's do this. Let me jump over here to my screen. Thank you, Samrita and Gigi Sudup. We're gonna come over here. Yeah, not tasty, but it does really look cool. Like it looks like something you would drink. So can we make this with precipitation reactions? And if we can, we'll learn a lot about solubility, about things like double displacement reactions, predicting what the products will be, spectator ions. We can learn all that stuff by making this here. And I actually have with me, let's see if we can go over there and get some light on it. A little bit better setup than last time. So you can see here I have all these different beakers and stuff we'll use to do the demo. All right. So here is the first thing we need to do. So last week what we did is we took this copper 2 sulfate right here, and it's all dissolved in water. So we know sulfate's 2 minus, so that's 2 plus. So in here we had Cu2 plus, and then we had the sulfate ion. Because sulfates here, they're real soluble. So this dissolves. Here, sodium's 1 plus, hydroxide's 1 minus, Na plus, OH minus. And we mix these together. And this is what we saw right here, this blue precipitate. So why don't we do that right now? We'll do that demo again. Put some light over here. Go back over to my beaker. All right. And actually, I want to show you this. This is the smallest beaker I own. This is a 15 milliliter beaker. It's very small. So we're going to do the first reaction in my little tiny beaker. Put it over here. So where is everybody coming from this evening on the chat? What countries do we have represented? I'm always interested in different countries. I used to live in Africa, in Ghana for a while, and Europe, so always interesting to hear that. Where are you from? All right, so I'm going to take this one right here. This is sodium hydroxide. Put my face shield on. I don't know if you call it cupric sulfate. I've always called it copper 2 sulfate, Jason. So right now I'm putting sodium hydroxide. This is a strong base. And Australia, that's like on the other side of the world. All right. So I'm trying to be careful. The strong base here is kind of dangerous. So I got that. And if I sound funny, it's because I have a face shield on right now. So that's why I sound kind of funny. And now we're going to put our copper 2 sulfate in here. See if we can get it a little bit less blurry. Let's move that over here. There we go. So watch and see our precipitate form. So as soon as that hits, we get this blue precipitate. It's kind of floating right now. Usually it falls to the bottom. If we tap it, whoa, if we tap it like that, it must be that the hydrogen bonding in the beaker is so small. Texas, hey, Loretta from Texas. There we go. That's our precipitate. And I have somehow managed to get some on my hand. So I'm going to take just a quick minute and wash that off. So while I'm doing that, let's have you guys go back over here and see if you can predict the products of this double displacement reaction. I will be back in a second before my fingers burn off. All right. Okay, I'm back. So you can tell when you get sodium hydroxide on your hand because it's slippery. So if I feel it slippery on my hand, I know I've got to wash it off. And I didn't feel any discomfort because it wasn't terribly a lot on there. All right, let's take this off. Ooh. So if you're looking at this and you're trying to crisscross applesauce, yep, Jason, you got it. So if you're trying to look at this and see what you might get, these are aqueous, so they're already dissolved. Oh, let's go over to the screen. There we go. These are already dissolved. There'd be an AQ after it like this. So they're already dissolved. We know they're soluble. The copper, that's positive, so the only thing it can go with is the hydroxide. So we could end up with copper hydroxide, but remember hydroxide's negative and copper's 2+. So you got to have two of those. My handwriting's looking like a third grader tonight. And then the sodium here, that could go with the sulfate. NaSO4, but that's 2-. So since this is 1+, we need 2 of these. So these are the products. And the big question is, which one is the blue stuff? Anybody have an idea which one is the blue stuff? I'll give you a hint. It has to do with, oh, Andy's from Florida. Awesome, Andy. I've only been to Orlando in Florida. That's the only place. So compounds that have copper are often green or blue. So that might give us a clue to which one we have here. But let's look at the solubility rules, because that's really, really useful. And I think there are links in the description that have the solubility rules here for you to use. Jason says CuSO4. Well, not CuSO4, because that's what we started with. These are your options here, CuOH2, copper 2 hydroxide, and sodium sulfate. CuSO4 is not the precipitate. But close. There is a Cu involved. So if we look at it, copper, we can't really tell. Another person from Florida, wow. But hydroxides, most hydroxides are only a little bit soluble or insoluble. Sodium hydroxide is an exception. But so this has to be insoluble. So this right here, that is going to be our solid. And if you look at our solubility rules again, elements with sodium in them, they are soluble. So that's going to be aqueous and stay dissolved. So you can use these rules here to figure out what your precipitate is going to be, because that is the solid there. So every chemistry test that any big exam is going to have solubility on it. It's just one of those chemistry things. So we predicted what we'd get, and we figured out which was the precipitate. That's a huge amount of chemistry. You can find videos on this in the description of this post. So let's try another one. Spectator ions. Yeah, your Na and your sulfate. Your sodium and your sulfates are spectator ions. Hello, lobster. All right. So let's do this. I got to put this here back on. I really want to make this stuff that I was showing you at the beginning. I think this is This is why I got into chemistry, is I like doing the chemistry stuff. Okay, so I'm going to move my little beaker here away. Let me put you back on the... So I'm going to use my little beaker here. And the reason I think that precipitate didn't sink to the bottom is there's a lot of hydrogen bonding kind of pulling the water to the sides of the beaker. So it's kind of a weird dynamic there. It's kind of interesting. All right. This is my next container. And I'm going to pour in sodium hydroxide. About right there. And let's take and put our copper 2 sulfate. Let's put the blue layer in, because we know the blue layer is copper 2 hydroxide. That was our precipitate. So let's drop it in. And hopefully it'll sink. I do not know why things are floating tonight. Oh, I know why they're floating. Yeah, surface tension. But what's happening is that I made the sodium hydroxide too concentrated. So it's really, really dense. And because it's so dense, that's why the stuff's floating. I'm going to put a little more water in there and see if that changes it. Let me grab some water. All right, so we'll put some water in here and see if that changes our density. All right, a little bit of a change there. And it looks like it's starting to settle to the bottom. So this may be, we may have to let this wait a bit. So let's let that settle out, do another problem here. All right, so can you predict what you'll get when you have these two here? All right, Scimitar, glad to have you here this evening. See you next time. Magnesium right here in group 2 is going to be 2+. So see if you can predict the products of this solubility, of this double displacement reaction. Because if you can, you are doing really well. You will do well on your next test. All right, Scimitar, see you next time. Okay. And for these polyatomic ions here, you really just have to memorize the charge on them, SO4 2-, OH-. Or if your teacher lets you have a table, that would be nice too. But lots of times they don't. All right, so what do we get? The Mg, the positive here, I like what you're saying, Christian. It's going to go with the hydroxide, Mg. That's our magnesium hydroxide, but remember, 2+, 1-. You could do the crisscross. You could move the 2 here and the 1 here. We don't really write the 1. Get rid of these charges here. Then drop your parentheses right around it. That's our magnesium hydroxide. And then we have NaSO4, but we had 2- and 1+. So we have to have 2 here. So which one's going to be the precipitate? When I mix this together, which one of these is going to be the solid? Will the hydroxide or the sodium sulfate be the solid? That's the question. You should already know that. Because last time we said sodium ions, always going to be soluble. So that's aqueous. Hydroxides, unless they're like sodium or some of these other ones in group 1 here, that is going to be the solid. So let's try it. Let's go back, drop this down. And now I'm going to put magnesium hydroxide right here. Magnesium hydroxide is Epsom salt. So it's just kind of a, you can buy it in the stores. Let's see if we get magnesium hydroxide from our reaction. You can kind of see it. but it's kind of floating too. I'm going to put a bunch in there. We may only actually get 2 layers tonight. Let's put a bunch of it in. All right. So we have 2 layers, and that's pretty cool actually. See if I can turn it a little bit here, like that. All right, we did it. We got 2 layers. I'm very excited about that. All right. So Epsom salt, you got it. Jason, what's causing the layers is really just that the blue formed on the bottom and the white precipitate is on top, almost like layers of sand. It's not quite as dense as sand, but it's more than just resting on top of each other right now. So can we put a 3rd layer of the blue on top? So Jason, that would, if that 3rd layer goes on top, then I'm guessing that that they're just resting on each other. So let me put a 3rd layer, go back over here. Let's put the copper sulfate. And the only reason this is working is because there's still some sodium hydroxide left. We didn't use all that up. All right, so can we put the blue layer? Oh yeah, look at that. We are the greatest. It's kind of harder for you to see here than it is for me. It's my camera really does not do this justice, and I played with it today, but as you know, I'm still learning. So let's see if I can give you a better look at this. Not as much as I would hope. But you can see right here, you can see the white layer and then the blue layer on top of it. So we are getting the layers, and I'll post a video of this. I'll do a video of this and post it later so you guys can really see it. But we did get our 3 layers. Let me do this. I can print the screen. And here's a picture of it. And so you can see the white layer here and the blue on top and bottom. So we were moderately successful with that. So let's go down and look at one more layer we could put on it. So give this a try. See if you can predict the products of FeCl3 and sodium hydroxide. We may just do this in another beaker. Oh, you're still looking. You're not looking at the screen. I'm sorry about that. There you go. See if you can do that. If you can predict the products of FeCl3, iron 3 chloride, and sodium hydroxide. All right. So remember, the metal will go with the nonmetals. Fe goes with the OH, but here again we have the negative and the 3 plus, so we'll need 3 of those plus Na plus and Cl minus, so salt water. And hopefully by now you know that hydroxides, unless they're like sodium hydroxide or potassium hydroxide, group element ones, that's going to be the solid. And here, this will be, salt, just NaCl is aqueous. And Christian, you got it. Jason, you got it, but NaCl, be careful, Na's plus, Cl is minus. So we would have to balance the equation. It's not balanced. You'd have to like put a 3 here and do some other things to it. Actually, I think you just put a 3 here. Would that balance it? 3 sodiums. You'd have to, I think that, you'd have to do some work to balance that equation. It's not balanced. All right. So let me do this. Let me take my webcam down off of, here, and see if it shows you any better. Yeah, can you see the 3 layers on there now? I think that shows it a lot better. This is my nice webcam. So there you can see the 3 layers better. But it's harder to move my webcam here. Let's move this back. All right. So now what I'll do is I'll put iron 3 chloride. I have a, where am I? I have this thing with iron 3 chloride here. It's a little awkward for me. And let's put iron 3 chloride in the solution here. All right. So it's not actually easy to see, but you see the red layer we're getting across the top? That is our iron 3 chloride precipitate forming right there on the top of the thing. So that's kind of cool. All right. So I think we're kind of headed towards a finish tonight here. I wish I had a big finale for you, but that was our attempt to do a 3-layer, put my webcam back up here. That was our attempt to do a 3-layer precipitation reaction. I hope you've learned something about predicting these double displacement reactions where you find the charges and then you make sure everything balances out here, as well as the precipitate. We can find the precipitate by finding which one is insoluble. And we use some solubility rules to do that as well. And so these are skills you really have to have. As you go on, you start doing net ionic equations. That type of thing really becomes quite important to be able to do. So these are the 3 equations we did this evening. And so if a teacher gave you those 3 on a test, you should be able to predict the products and say what's going to be the solid out of them. So why don't we wrap up, see if I can go over to my beaker here. Hello, Darshira and ADHIP05. Let's do one more demo here. Find my webcam. And I'm going to put the iron 3 chloride in with the sodium hydroxide, just because it looks kind of cool. And then I'm going to put some copper 2 sulfate in here just for good measure. And we still have that that density problem, Jason, we were talking about, where it's floating. And then I'm going to put my magnesium sulfate on the other side. Who knows? I got red. If I get red, blue, white, maybe I can make a flag. There we go. Oh, I messed it up. There's some of the white, though. You can't see it as well because it's white paper, but that is our reactions for this evening. So I want to thank everybody for joining me here tonight. We will be back Tuesday. I think it's Tuesday. And do some more chemistry. If you have any ideas, you can always leave a comment on one of my videos or email me at drb@breslin.org. And if you look in the description of this stream here, you'll find all kinds of links to the chemistry that we did here. I'll stick around on chat for a few minutes, but thank you. What's the solution under the flask? The clear stuff, sodium hydroxide. That's what I have under there. So pretty strong base. Excellent. All right. Thank you very much, everybody, and I'll see you next Tuesday. As always, this is Dr. B, and thanks for watching.